you'd better enjoy this, Trevor, because it's still here.
Yes.
But there are some plans afoot to actually dig this up for gravel.
I know, I've written a submission to the Shire
And
to tell them they should not.
And I'm very glad you did this, because this is one of the very few locations around Northcliffe where you find the Albany pitcher plant, which is an iconic species here in the southwest. It's an iconic species. It fits in its own genus, in its own family. It's really very special, and people travel to WA to actually see that particular species here. And if you dig this up for gravel, those people won't come to Northcliffe anymore, and they won't be staying in lovely cottages that are all around here in Northcliffe, and they won't be bringing in their money anymore. You can dig it up for gravel, and you can make money out of that once, but people keep coming for a very long time to come if you leave it alone and let them visit all these wonderful little plants. This is just one of them, the Albany pitcher plant, but there are also all these little areas. There are all these sundews. There's dozens of different plants over here, all with their very special adaptations. This is really a very special place. My advice is leave it alone, show it to tourists, make them enjoy it, and bring in tourist dollars in the process, and don't dig it up. That's
Absolutely.
my simple advice.
I totally agree with you.
This is the Albany pitcher plant, yeah, and it's really iconic. It only occurs in the southwest of WA. It fits in its own genus, in its own family, and both the genus and the family are endemic to the southwest. It's actually the only species in that genus and in that family. And they look like pitchers from elsewhere in the world, but they are not at all related. So that discovery to make these pitchers, to catch prey, that's how they get their nutrients, that discovery was made independently by this particular species and a lot of other pitchers plants that you find in the rest of the world. And next to it you'll find a little Utricularia over here, and you'll find some Drosseras over here. So that trick they play to catch insects, well, it's not the only one that plays that trick. And the reason for that is, if soils are really poor, then you've got to find all sorts of tricks to get your nutrients, and catching insects or other prey is one of those tricks. So this is paradise for carnivorous plants. So this is one of many Gastrolobium species, poison pea, that we have here in the southwest of WA. And it's really poisonous because it contains fluoracetate. Now fluoracetate is perhaps better known as 1080, so we use that for baiting of feral animals, foxes, cats and what have you, that are a menace to our biodiversity here in the southwest. And we can use that because all the native animals, they have co-evolved with this poisonous plant, so they can cope with 1080. They are not poisoned by it at all, but the feral introduced animals, they can't actually cope with it. Now I can predict that this one is particularly poisonous because this one doesn't have spiny leaves. It has rather soft leaves, and you think, oh, I can eat them. Well, the Gastrolobium species that are not spiny but really soft, they have truckloads of this poison, and the ones that are actually spiky, they are defended in a different way, so they tend to contain a lot less of this poison, fluoracetate 1080. So outside WA, there's only a few places in the world where plants accumulate 1080 fluoracetate. One of them is in Brazil, where there are a handful of species, and the other one is in South Africa, where there's also a few species that produce this poison. Outside that, there's no known species that actually accumulate this poison. So don't eat it. And farmers know about this, because whenever there was Gastrolobium about, they did not like their sheep, goats, animals, other animals to roam into the bush. because they quite often wouldn't come back at all because it is really a respiratory poison. This Uticularia violacea. Wow! So this is Uticularia multifida, and this tiny little species is Uticularia violacea.
Do you know which one? It looks like the carry one to me, but I'm not certain
I
it is.
don't know enough about them. No.
What, the Gasterobium?
Wayne, do you know?
It's amazing.
Yeah, we can do that.
Alright, I'll just film you from here because then I get the whole landscape.
Yeah. Well, we saw a few of the Uticularias before, but this is a carpet of pink petticoats, Uticularia multifida, and I've never seen such a carpet of Uticularia multifida together. This is absolutely amazing, and I bet you, if you come here earlier in the year, it will be red, because then the red coats are out, and they will also love this environment. And you can't find them now anymore because they stopped flowering, but it will be look equally impressive, but then red instead of the pink over here. There's another species as well, that's violacea. We saw that back there, but I haven't seen that here yet. So this is really, really very spectacular. They love the wetness of the granite rock, grow among the moss, and when it all dries out, then they disappear. And in the moss they've got that little suction traps, and they catch the prey with their little suction traps in that moss.
And then like, setting itself up.
Pink petticoats. That one. So they've got little suction traps in the moss.
Is that
Carnivorous plants.
yeah, which one?
Uticularia multifida.
Uticularia, still Uticularia.
So I just dug up one little Uticularia multifida to just show you the little suction traps that are really hidden in the moss. And these suction traps, they have a little suction tension, and they have got a little trap door, and as the prey gets near it, the door opens and the prey actually gets sucked in, and actually gets invited for breakfast or for lunch or maybe brunch actually this time of the day. And they really enjoy it. Well, that is to say, the Uticularia enjoys it. I'm not so sure the prey enjoys it as much. So, lovely little traps. I think I've got to show that to the others as well. And then put it back. So what we got over here is a trigger plant, Stylidium. And if you look at it carefully, you can see the stamen. I'll touch it in a minute. You can see the stamen pulled right back. And they're called trigger plant because the idea is if a pollinator lands on this, you trigger the stamen, and it actually moves forward and hits the insect on its head, and a little bit of pollen then gets attached to the insect, and the insect is a bit dazed by all of this, but then moves on and moves to the next plant, and it actually pollinates the next plant. So that's Stylidium, a trigger plant. We've got lots of them in the southwest.
You got an orchid over here that's opening up?
There's an orchid opening up, but I can't give you a name of that. It's not quite open yet. Maybe Wendy can help with a name.
It's a remarkable place.
Oh, this is just absolutely remarkable. So you see more of these utricle areas, and there's a Drosera over there, and amazing. Gosh, I've never seen anything like it.
I think this moss is seedy.
A lovely little prickle plant there. So this is Acacia pulchella, prickly Moses, and it's called prickly Moses for very good reasons. But that's not what I wanted to talk about. It has galls over here. These are quite old, the red ones and the dried up ones, and these are quite young, and these galls are actually induced by a little, likely an insect. I don't know which animal actually does that in this particular case, but that insect lays an egg or more eggs on the leaf and then tells the leaf to, well, to basically build a house for it. And what you see over here is all plant tissue that has been produced, induced by something that is released by the larvae that hatches after the egg has been laid. And that larvae then lives off the material that is produced by the plant. So it basically tells the plant, bring all the goodies to my little home, build cells for me, and the larvae then eats the cells until it's ready, and then it crawls out of its little home and flies off. The insect flies off and lays its egg somewhere else. So you see that a lot of these acacias, they are full of these galls. The galls don't actually kill the plant. They don't do it a lot of good either, but they don't actually kill the plant. It's absolutely amazing.
Is that what that is?
It's really fleshy.
Yeah, so there's the little,
No idea what they were until
little
you started.
galls, yeah.
Really
Yeah.
fleshy on the outside, and then you've got like a harder, like a nut in the middle. There we go.
Prickly Moses, I know about that. It's one of the veins of an oriental existence.
Oh, they're really quite hard, aren't they? You need
Yeah, and we've got two.
you need a knife to get them
coats.
open. Yeah. This is a Thomasia species. I think it's Thomasia lesiopetalum. I will have to check that. And what's interesting about this one is it has its flowers hanging down, which seems a bit unusual. If you want to be pollinated, you want to expose your flowers. Well, this one is exposing its flowers because this one is actually buzz pollinated. So a native insect, most likely a native bee, gets in, gets under it, and then buzzes, and because it produces the right frequency, the pollen gets dropped on the little insect, the insect moves on and pollinates the next one that it actually visits, where some of the pollen then lands. Thomasia lesiopetalum.
Interesting, because it does look a little, the leaves look a bit of look.
So what you see a lot here on the rock is these boreas. We call them resurrection plants, and I'll tell you in a minute why that actually is. They're really green now, but as it gets closer to summer or past summer, they really dry out and they absolutely die, or so you think. But you pour a little bit of water on it and they basically come back to life. So that's why they're called resurrection plants. And they're really very special. They turn on certain genes that are not known in other plants except in their seeds, because seeds also dry out until they are in equilibrium with dry air. So those genes are turned on and they actually protect, they are responsible for the synthesis of proteins that allow those seeds to actually cope with those very dry conditions. So in seeds it's quite normal, but here we find exactly the same genes, and they are turned on in the vegetative parts of the plants, and they encode very similar proteins that protect these leaves against drying out. So resurrection plants, they're very typical for rock outcrops where the environment is such that it really dries out. What we're seeing here is a peppermint actually, but that's not what I want to draw your attention to. I really want to point out that this young foliage, unlike the older leaves, the young foliage isn't quite green yet. And as the leaves get older, they gradually change from red to green. So what they're actually doing is they've got different pigments in the young states from the old states. Now those green pigments in the old states, they are important for photosynthesis. But they haven't produced their photosynthetic apparatus yet at a very early stage. What these plants are really doing is they really invest their phosphorus, which is a key limiting nutrient in this environment. They really invest their phosphorus in a very efficient and very clever manner. What they first do is they build their leaves. They build the cells, and that takes them a while. And after they have done that, they recycle all the phosphorus that is needed to build that leaves. And now they are going to use that phosphorus to build the chloroplasts in which all the green pigments are sitting. And those green chloroplasts, they are needed for photosynthesis. So they first use the phosphorus to make the cells, then they recycle that phosphorus and use that same phosphorus to make the chloroplasts. And so that's why they are not green yet. There's all the reason why they are not green yet. They have red pigments, and those red pigments, they are very important to protect the leaves against the high radiation, because the chloroplasts are not going to absorb that light, so it really hits those leaves, could potentially damage them, but the red pigments actually avoid that. So they basically have their own built-in sunscreen, if you like. And as the leaves green, the chlorophyll accumulates and those red pigments are broken down because they are no longer needed to protect the leaves. So it's actually a strategy to save phosphorus. Wow. And the paleobotanist may have talked about algae that had the red pigments. That's quite possible, but that's a different story from this, because these pigments are not important for photosynthesis, whereas in algae they are, in the red algae and brown algae they are. But here they are just protecting compounds against the high sunlight.
And you said it was called the peppermint tree?
It's a peppermint, Agonis flexuosa.
Wow, yeah.
You can smell it, can't you?
You can smell that.
Yeah. Well, in this little patch we see three parasites, and one of them is a hemiparasite. With that I mean that it is green, which basically means it can photosynthesize, but it's actually pale green, so it doesn't do a lot of photosynthesis. It's a hemiparasite, can photosynthesize, but it is not very good at taking up nutrients and water from the soil. And it basically attaches itself below ground with little hostoria, little suction cups, to surrounding plants. And I can't tell you exactly which plants that may be, but it's probably not very choosy, and it probably attaches itself to a whole range of different surrounding plants. And it basically extracts all the goodies, water, and more importantly nutrients, from the surrounding plants. And it does that by sucking very hard, by transpiring very fast, so it creates a suction tension, and that's how it actually allows the movement of the nutrients from the surrounding host plants to the parasites. So it's a hemiparasite. And a little bit in that direction we see another one. Oh, there's one standing over there. That's another hemiparasite. That's Exocarpus. And then here we have got a holoparasite. And that is a little bit green, but it doesn't actually do very much in terms of photosynthesis. This one steals everything from the host plant. So it doesn't photosynthesize, it steals the carbohydrates as well. And that wasn't particularly good for the plant, because this plant has actually been killed. And that could be due, I can't tell for sure of course, that could be due to this parasitic plant over there. So this is a dodder, Cassis.
We're right next door to this wonderful flowering plant. I'll just ask you what it is.
That is Pimelia rosea. And it could be parasitizing on the Pimelia. I don't know, but it's it's quite common over here. And that little thing over there,
The spiky looking one?
that spiky little one, that's Exocarpus. That is also a parasitic plant. So this is Hardenbergia. I'll pronounce it in the German way. We would say Hardenbergia. Hardenbergia comptoniana, or the native wisteria. And it's actually named after the Countess of Hardenberg in Germany. And the Countess of Hardenberg had green eyes, and the person who named this species, this genus, was actually a little bit in love with the Countess. And you can really see, if you carefully look at the flower, you can see those green eyes in the flower.
Romance, eh?
That happens in academia too, you know. So this is Fish Creek, and what I would like to point out here is all this limestone. Where does it come from? Well, imagine the sand that actually comes in from the ocean. That sand is partly silica that got washed off the continent, and partly calcium carbonate, shell fragments, epiphytes from seagrasses. They all wash on land. And those shell fragments, all these epiphytes, they contain a lot of calcium carbonate. That calcium carbonate gets dissolved by rainwater, by acids that get released from plant roots. That dissolves, and then when it dries out again, the calcium carbonate precipitates, and that leaves behind the limestone. So the origin of all this limestone is actually the material that comes from the ocean. Shell fragments in particular, epiphytes from seagrasses, and all sorts of other little animals that are very rich in calcium carbonate. They're also very rich in phosphite. They are locked up in the shells of animals as well. And that's why these young dunes, they tend to be very rich in phosphorus. So they are rich in calcium carbonate, that gives them a high pH. They're also very rich in phosphorus, and lots of plants love that here. Those are the plants that do grow here. A lot of plants also absolutely hate it here, and they can only grow on those older dunes when all the calcium carbonate has been washed out and has been precipitated, and when all the phosphate has disappeared as well. And we end up with a totally different vegetation, actually a much diverser vegetation than what we have here close to the ocean. And that is basically because the poorer the soils get, the richer the flora becomes.
This is the Lepidospermum
What would you prefer, tea or coffee?
gladiatum, coastal sword sedge. And where I come from, this is the first of the coastal bush tuckers. It's got a very mild flavoured base, stem cell base. You just break it off like asparagus. It'll break off where it wants to, and away you go.
I had to. No.
Yum.
I get about 3 kilos of this every summer.
Really?
I just guts out on it. And then you got the leucopogans after that, and then you got the pig faces after that.
Yep.
Oh, there you go. He wants to.
What are we looking at?
Looking at a blue-tongued lizard, bobtail. Native, yeah. Oh, he's very timid, this little fella, aren't you? Hey.
Are they common in the southwest?
Oh yes. Come on, fella. Come on, you're okay. No one's going to have you for lunch, eh? Come on. You've decided I'm not going to hurt you now, eh? Shingleback or... Yeah, you're alright. Come on.
Oh, look at that. How gorgeous.
We're up in Kalbarri National Park, and there was one on the road, and I stopped and I picked it up.